And okay. Let's start with 3-3. There's not much to summarize for 3-3 because 3-3 is just a repeat of 3-1 and 3-2. And chapter 2 actually kind of ties it all together quite nicely. So 3-3 is about grouped data. And for this, you're going to be estimating. Often it's estimating, sometimes it's not. Estimating center and spread. From grouped data. So you're thinking of, you should be thinking you're going to have frequency distributions, which we looked at in chapter 2. And these frequency distributions will have classes with lower limits and upper limits, all that mess. And then just as a reminder, center and spread, what we're looking for, I don't know that anyone needs to write any of this down because you already have, is this mean, median, and mode. And then for spread, we're looking at standard deviation, variance, range, and then you might have gotten there yesterday, IQR. You also might not have, no worries. And it's just knowing how to calculate these in StatCrunch. And there's a few little interesting things we have to keep track of, and we'll be good to go. So for 133, one of the worksheets you're going to be turning in is the 3-3 number 2 worksheet. So let's do this one, shall we? What I think we should all do is get into StatCrunch, and I just want to start there. So log into your StatCrunch thing, get yourself to a worksheet, and I'm going to enter this information into the worksheet. Now, you don't need to do everything I'm doing here. I just want to make sure it's clear what's happening. So first, let me not forget to practice reading. I always want to. So we got, suppose the statistics course has the grading scale given in the table below. Not really anything special other than I need to note that I'm looking at this table for the grading scale. You should recognize this because this is how you're going to be graded in this class, or how your grade is calculated. Great question, Brianna. This is page 503.
503.
Yeah. So this, you should be familiar with this. I forget if I highlighted it, but yeah, no, remember 50% of your grade are the 2 exams. 20% of your grade are the projects. We're going to be doing a couple of them today. 10% is that stat lab. Remember, this is now double jeopardy because the assignments you're doing for this are the same assignments you're doing for 033, which are 25% of your grade. And then these worksheets that we're completing right now, that we're working on in class, are 20% of your grade. So we are to find your course percentage. Yikes, that's an interesting thing. And then course grade. And here we're supposed to look for our syllabus at what's the breakdown for that for each of the following. So there isn't actually, to me, any vocabulary words in this that we particularly know, other than when you see this course percentage, you need to know that this is really what we call a weighted average, which you did in 3.3. And you can also think about it as grouped data, because these are the groupings, and this over here is the data. Okay, so let me now finish typing. So I am typing in the categories. Now, you're going to find in the math world, in the stats world, let's say that when you create tables, you always put the X value first and the Y value second. And when it comes to tables like this, where it's grouped data, or like this, the data values are always the first column, and the frequencies are always the second. So that also means when we create classes down here, these classes, those are the data values. They're just not particularly useful for calculations. We have to turn them into midpoints in order to do calculations. So the reason I'm highlighting that is because here we're given a scenario of a particular student who earned a 76.1% in their homework / classwork grade category. That's the data value. That value was collected for that particular individual. So I'm going to put that in as 76.1. And then the weights, which in this case, we call them weights because this is a weighted average. 20% of the entire grade is that classwork homework grade. So the weights here are these things, and they correspond to the frequencies. That's kind of the connection between a weighted average and a group data set. All right, so let me fill in the rest here. 45.6, 89.4, midterm of 73, final of 68. So how about you all get this stuff in your StatCrunch, and then we're going to calculate the course percentage. So maybe give me a shout out when you're ready. You know what? I didn't get coffee today. I'm going to put a pot of coffee on while you all are typing. And then it's going to get crazy, but that's okay. Sometimes crazy is good, right? Okay, are we ready?
Ready.
Let's do it. So first, let me tell you what StatCrunch is about to do. It is about to multiply the data value times its weight. And then it's going to add up all of those products, and it's going to divide by the sum of the weights. If you recall how your textbook wrote this formula out, which you don't need to know, but sometimes it's nice to know what's going on. It's the you know what? It's not nice to know what's going on in that formula. The formula is maybe not helpful. So we're going to ignore that. So just know it's going to do this times this, plus this times this, plus this times this, divided by 100. So you're going to go to stat and summary stats and look at this nice little thing at the bottom, grouped binned data. Remember bins or StatCrunch's word for classes. So I'm going to click that. And we just have two options here. We just have to say, where are the bins? That's the classes or the groups. So that also means the data. And then where are the counts? Counting corresponds to frequency towards how many, that's the weights. We're going to leave the midpoints defined by the limits. And all we want here is the mean, because that's going to be your course percentage. Now, I just realized I clicked that really fast. Did everyone get it?
We did it like 10 times yesterday, so I think they probably got it.
You all good? Am I taking way too much time? Should I just turn you loose on this?
No. A refresher is good.
That's true.
I appreciate the refresher. I've got my 4-year-old sitting next to me screaming, so.
Oh.
Yes, refreshers are good, but they probably remembered the group bin data because we did do it a lot yesterday.
Where it says bins in, it has the VAR1 and the VAR2. Did I do something wrong or?
No,
Totally fine. You just had more stuff than you needed.
Oh, okay. So I pick VAR1.
yep. Just go
Okay.
in order. Just go in
Oh.
Okay.
order.
You didn't relabel them,
No, I didn't.
which is fine.
Okay. That makes sense.
That's,
Okay.
yeah, that's the difference. I just do that because it helps me keep track of what's where. Anyone know what this grade is, by the way, in the class? I better pull up the syllabus.
That would be a 2.0.
Yeah. Does everyone know? You all know that? That's a 2.0?
I think they gave the grading scale in the book yesterday.
Oh, yes. Yes, I do remember that happening. A little note here. Did you know that, so I round to the nearest percent at the very, very, very end. I don't do any rounding until the end. And so that means an 89.5%, if that's what you earned when all is said and done, that is the lowest possible 4.0. Now, did you know that when someone looks at your transcripts, all they see is the 4.0? So a student that earns an 89.5% performed the same at the same level as a student that earns 100% at the end, because all we see is the 4.0. We don't see the percentages anymore. They get buried into the cyberspace. And the difference in terms of work that it takes, I got to stop saying these things, to get a 4.0 or 95, a 100 and an 89.5 is probably exponentially different. Okay, I'm going to let you just finish this worksheet then, unless you all have questions. Let me ask this one. Anyone bothered that I put these things in here as whole numbers and not decimals?
I mean, I wasn't gonna question it too much, but I was questioning it.
So let me put them in as decimals and let's see what happens.
I think you can put the data in as decimals, but not the weights. So you guys remember when I kept telling you guys yesterday that if you have relative frequency and we have decimals in there that we can't do a group bin data, but we never got an example where that happened. But we hadn't got to where this happened, Eric.
Nice. I don't know. I think she may have taken those examples out. Yeah. So it says, oh, they must be integers. Turns out there's a workaround. You go to stat, calculators, and custom. And you can do it with the decimals. Now, this one's a little different because it says where are the values? That's going to be your data. Where are the weights? That's going to be this. And here we get the same number here. Notice that it reports it as a 0.7291. So it reports the percentage we have over here as a decimal. It doesn't matter whether you convert decimals to percents or percents to decimals. What matters in terms of getting a correct calculation is that you're consistent. If all of these are in percents, perfect. We could have put these as decimals if we wanted to. Cindy's totally right. Grouped bin data, this option only works if your weights are whole numbers. Because what StatCrunch is thinking is that you're providing a how many count. And if you tell StatCrunch that this is 0.2 of a something, they're like, no, you can't count that way. That it doesn't work. That's why you'd have to use that custom calculator. We will use that in chapter 5, I believe, because there might be some times. There might be a time or two where you have to. For now, we can just work with group bin data. For B, I'll just do this one and then turn you loose. You're supposed to see what happened if the student worked a little harder in my stat lab, and instead of failing it, they got a 90 in that section. What does the grade become? So again, data weights, I just need the mean, compute. Oh, it's a 77.35. Big deal?
Yeah,
Yeah.
it's up to a 2.5.
Yeah. Of course, once you're in the nursing program, no one cares anymore what your GPA was from before you got in. They care in the nursing program. And then when you get out of the nursing program and they hand you that piece of paper, the hospital doesn't care as long as you've passed the NCLEX. And then once you're hired, they no longer care about any of that. They care about your years of service. And maybe how many patients you kept alive. I don't know. I don't know those things. Cool. Okay. Let's see y'all do this one. Number 2. I will keep myself from talking for 10 minutes. Set a timer for 10 minutes. maybe I should check in here real quick. Do you all know what in StatCrunch gives you the total number of movies seen? And what gives you how many people took the survey? Just in case you're forgetting, this is N, and this one is sum. And this one is mean, median, or mode. In this context, we're saying it's the mean. How are we doing? I'm thinking maybe 10 minutes might have been too much. Does anyone have any of the answers? Or is anyone?
Yes, no, maybe.
Yeah, anyone lost? Are you good? You just need me to leave you alone for a little bit longer and calm down?
I see an answer.
There we go. Okay, nice. Okay. All right, I'm gonna pull up the summary stats on this and we'll see if I agree. So I said we needed N, we needed sum, and we needed mean. Yes, I agree with A. Now, number 2, 0.385. How'd you get that? So it's a tricky one. So one of the things you can think about, what is it asking? How many movies were seen? So if we go over here, the in a month part doesn't particularly matter. This is just, we went out and asked these people, okay, last month, how many movies did you watch? And what this is telling us is that for a particular month, there were 4 people that watched 0 movies. So those, we don't need to worry about those because there's 0 of them. For this category, 3 people said they watched 3 movies. So that's a total of 3 movies. Let me try again. 3 people said they watched 1 movie. So that's a total of 3 movies for this group. And then for this second one here, we've got the number of people, there's 10 of them that watched 2 movies. So that would be 20. If you think about what this data set actually looks like, I could start typing it into StatCrunch here. It would look like this: 4 zeros, 3 ones, 10 twos, and immediately I'm like, I'm done. I don't want to do it anymore. That's why it's grouped this way. This is a discrete data set because you can't see half a movie, we're assuming. So nice, Laura, good. Okay, added both sections. What sections, Brianna, are you referring to? I think you're thinking a little bit like what you would do for C, where you add up the total number of movies seen and divided by the total number of people, and that would get you the mean. Got you, yeah. So if you adding these up isn't actually particularly meaningful. This is the data values that we're collecting. And we've just said how many data values were 0, and there's 4 of them. So in StatCrunch, when we calculate the sum, what it does is it adds up all of the data values. So the 4 zeros, the 3 ones, the 10 twos, the 7 threes, and so on and so forth. And we get that for this particular group of people, or this group of people, cumulatively, they watched 107 movies. And we get that by using the sum function or feature in StatCrunch. And then when it says, what's the average number of movies seen? We're saying, well, if we divvied up these movies amongst all the people we talked to, all 39, how many would we expect each one individually to watch on average? That is actually calculated by taking the sum, what is going on with my screen, and dividing by the people, which is exactly what StatCrunch did here. Approximately, note 2 decimal places, 2.74 movies. Does it bother anyone that this mean is 2.74 movies?
I was gonna say not anymore, but that's just, it used to. I was just in Laura's shoes.
Yeah, Laura, I'm with you. Like, you can't. Well, you can't watch half a movie, but watch what happens when I take this 2.74 and I multiply it times the 39. We get 107 movies. So that's what an average is. It's like, well, what if we equally distributed there's our 10 minutes. What if we equally distributed the total things we have collected among each individual? What would we get? We would get that on average, each person, there's 2.7 movies watched per one person. That's what this number is. It is rare that, especially with discrete data sets, that the mean matches a data value. Did we talk in this class about birth rates? Was that here where I talked about that? You think about the birth rate of a country, it's defined how they calculate it. They take all the babies born in a year and they divide the number of babies by how many women of childbearing age are in the country, because we don't care about the men. And that's your birth rate. And it's your country will die or will disappear if your birth rate is below 2. Because it takes 2 to create 1, and it takes 2 to replace the 2 that were created. That means to break even, because the 2 that created someone are going to die eventually, and then that person replaced, right? So you need a birth rate of over 2 births per woman in order for your population to survive, like stay stable. And if you followed Elon Musk at all, he believes that the greatest crisis of humanity is we dying off. So he's been having babies with different women, apparently. Okay, how about I give you 10 minutes to fill in this old school thing that you're going to do again when you take the midterm. Everyone remember class midpoints, relative frequency, cumulative frequency, and cumulative relative frequency? I can show you how to calculate all of this in StatCrunch if you would like. But someone has to ask me to do it.
Nobody showed me how to do it in StatCrunch, Eric.
You want me to do it?
Yeah,
do it.
I've never seen it.
Do it. It's kind of a pain, but we did it in the in-person class, and it wasn't actually too bad. Maybe it's because I'd done it a couple times. Okay, so I'll walk through it. First, the midpoints, let's get that. There's not really a nice way to get that in StatCrunch. It's not too crazy, right? We do the sum of consecutive lower limits divided by 2.
Laura has it for you.
Thank you. Okay, there we go, 20. And what's the width? That looks like 10, so 20, 30, 40, right? Dot, dot, dot. So I will type those in. Do I need to pause and let you all type in this stuff first? Yes, I know I do. I'll go check on my coffee. All right, was that enough time to type? Oh, okay, more time. Look at me making assumptions. What page number? Great question. This is page number 504. Yay, got it. We will have to debate whether or not this is a faster method than just doing it by hand, or manually entering it in the calculator.
So you guys, I will mention that if you happen to have the old course pack, that this page is different. So a lot of the pages so far of our worksheets have been the same, but this page is different from, so this would have to be printed off from the new worksheets.
And that's a good point. I remember grading a midterm last time I taught this, and this was, or the final, and this was the question on it. This was the exact midterm question. And I took off a lot of points on this one because people got the context wrong.
Okay, I'm ready.
Okay.
I don't know if everybody else is, but I'm the one that
Thank you.
said no.
Okay. Anyone need a little more time to type? Okay, let's do it. Now, I wrote these things in here just to remind me I need to calculate these. What's about to happen is we're going to have columns are auto-populated. So it's a different column, or it's a different menu. It's the data menu in compute. And we're going to build an expression. So it opens up this compute expression. If we had everything memorized, we could type it here. I don't know that it's worth our time trying to do that. So click the build, and there's this huge list of functions here. And then there's the list of our columns. So here's our midpoints. Boy, I spelled that wrong. Here's our frequency column. I labeled them that way. If you didn't relabel your columns, you'll see var1 and var2. So what we want to do first, remember how relative frequency is. It's divide each class frequency by the total of the frequency. So the sum of all the frequencies. So we're going to take the frequency column and we're going to divide it by the sum. So we'll come over here, I'll hit S and it goes down to sum. Except I shouldn't have done that because you can actually just type it. Here I'm just double clicking, it puts parentheses, and I'm going to put frequency in there, and that's going to do it. It's going to take each row and divide it by the sum of all of these. How are we doing? I'll pause right there. Still too hot. Talk to me.
Can you do it again, please?
Definitely. Yeah. So one of the things about this is you actually have to know the formula. You have to know what's happening because you have to construct it. So what we're wanting to do is divide each class, so each of the frequencies, by the sum of all the frequencies. So I click the frequency column, and that tells StatCrunch, take everything in this column. I click the divide button, and I want to divide it by the sum of all the stuff in that column. So I double click sum, and I double click frequency. I should say this, if you're like, oh, this seems too complicated, this is going to get in the way of my learning, then ignore me. Don't do this. You know how to type this in your calculator and figure it out, right? Notice here they are. I can do it again if you want me to. By the way, note that
Yes, please do it again.
Okay, I'm going to do it again. Note that when StatCrunch put it in here, the title of the column that it created is the formula we rewrote. Now I cut it out of here and pasted it over here. That's what I did, but I'm going to do this again. So let me delete this column, and here we go. So if we want to compute something, if we want to manually put together the formula, we go to the data column and compute an expression. We then want to build it. And so it opens up this calculator side, the column side. Notice there's now a relative frequency here because I have numbers there. We don't want to mess with that. And I'm just double clicking frequency, or you can click the add column. I'm dividing that by, and then I'm going to find the sum. Now this time I'm just going to type sum, and then in parentheses, I'm going to click frequency again, and you have to close the parentheses. Otherwise StatCrunch you can't handle it. Click OK. The expression that you just created, you see it right here. Click compute, and there it shows up. There's this dialog box that's useless. It just says, hey, there's a new column. Go find it. It's somewhere in your spreadsheet. And that column is labeled this, and it has the data added into it. So this dialog box isn't helpful. Here's the stuff we needed. Now notice these are the decimal versions of the percent. We could actually mess with this and get it to give us the 3 decimal places we wanted. Nope, we're good. We didn't need to write it as a percent. So when you write it down, you could round this. We could also tell the calculator to round it to 3 decimals. How are we doing? You ready?
Everyone's quiet.
I'm assuming you all you got it. You love it. Okay, now for the cumulative frequency. So I'm getting scared, like maybe I don't remember how to do it, but let's see if I can do it. So the cumulative frequency, remember how that worked? Like the first one was just the first frequency, and then we had to add to that the next frequency. So this was 84, 82 plus 10, 507. And the next one was that added. So we're just adding the next frequency to the previous. That's the cumulative frequency. So we're going to go into building again. We're wanting to add up the frequencies, and there's a function in here that I'm going to call the cumulative sum function. And you will see the shorthand here in the second. Here it is. That is the cumulative summation function. That's what that shorthand is for. I think it's kind of an unfortunate abbreviation, but you know, we're adults, we'll handle it. So that's it. You just do that. You want to add up the frequencies. You want the cumulative summation of the frequencies. So, okay, compute, and there it is. Magical. That is the cumulative frequency. And there it is. Should I
I'm
do that
having
again?
an issue. I'm having an issue because I'm seeing your face instead of what you're doing. It's literally the smaller than the palm of my hand on my screen. Because I have it split to where I can see our Zoom and StatCrunch, so I don't have to click back and forth. So if you
There you
could
go.
share your
Is that better?
screen, maybe,
Well,
because
it's on your end. You have
oh,
to pick how big you want.
there we go. That's better.
You
Okay,
got it?
yeah.
You want to do like something, yeah. Okay, good. No, I clicked the wrong thing, so now I don't know where I am. Shall I do that again? Could I just close it? Where did it go? Well, that's fun. Looks like I just closed that window. Okay, let's do it again. The good news is I get to type everything in again. And I'll do everything again since I have nothing else in there. And I need the relative frequency and all the rest to make it work. Okay. Okay, so midpoint and frequency. And we wanted I'm going to do the relative frequency first. So I'm going to data, compute, and expression. We're going to build this expression. And I want the frequency divided by the sum of the frequency. So this is the total number of people that died in these car accidents added together. Click OK, click compute. Oops, I did it twice. There it is. I did that super fast. I hope I'm assuming you all were good with that one. So the cumulative frequency is we start adding up each of these, adding together the frequencies. So we just go to data, compute. This one's a little simpler. It's just the cumulative sum function. If you want to find it in the list, it's right here. And we're doing that of the frequency. Click OK, click compute. There is the cumulative frequency. How are we doing? Misty, is that better? Good. So here's the thing. You're most welcome. This is supposed to speed things up. If this slows you down, then this is a waste of all of our time. All right, the next one, the cumulative relative frequency, I can use the same function I use for the cumulative frequency to calculate the cumulative relative frequency. I just have to do the cumulative summation of the relative frequencies. Or I could take the cumulative frequencies and divide it by the sum of the frequency. Either of those two gets us the exact same thing. The one I did with my day class, we're in the day too. The in-person class was the cumulative sum of the relative frequencies. And there you go. How do we know we got it right? Because the very last row is 100%. It's a 1. So this is the cumulative relative frequency. Okay. Happy? Sad? Coffee?
Coffee, and I'll be doing that by hand.
Okay, do it by hand. If that was not helpful, do it by hand. Okay, so we now know the answers to all this. How about you now answer the other pieces here? And now, the only like thing that's directly from this is here. How are you going to calculate that mean and standard deviation? And hint, you're going to do it in StatCrunch. So 5 minutes to work on this. And then I'm super interested in your answer to interpret the values in the context of the situation.
Do you guys need to see his, like, if you didn't do that, do you need to see his entire StatCrunch table?
That's a good
To
call.
get- Okay,
There we go. Set a timer for 5 minutes.
yes, Brianna.
Yes, good call. Because of that. That was a long 5 minutes. What would you all say for number B?
Me too, Laura.
Nice. So I didn't explicitly calculate it anywhere here, but where it shows up is right here under the cumulative frequency. It's the last class's frequency for that. Good. Would you all say is the lower class limit of the fourth class?
Yep.
Good. So 1, 2, 3, 4. This was the fourth class. Here's the lower limit in case some of the others didn't see. What's the shape? Ooh. Anyone know that one? What? What? Why is it?
I thought skewed right as well.
Yeah, I agree. If you could turn your paper on its side and draw what the heights of these bars would be in a histogram, maybe we'd have something like this, and then something like this, and then this one, let's see, this is my x-axis here. This one's a little bit shorter, and then it's a little bit shorter still, and even a little bit shorter there, and then a lot of bit shorter, and then a little bit shorter. So yes, that would look skewed right. I guess we should say skewed right. Good. Okay, excellent. How did you feel about this being a population? I think I said what because of the histograms that were being drawn. I didn't even read your text. Sorry. Is it a text? Your chat? It's like sometimes you just shouldn't listen to me. Well, okay. What was the clue up here that said, yeah, Laura, excellent. All fatal motor vehicle crashes in the US in 2019. Good. It could depend though, because what if we're looking at the trend of fatal car crashes from 2000 to 2022, right? Then this would be a 1 year out of all that, but we're not looking at years, right? We're looking at the age of death. So it's everyone for 2019. Good. What did you all get for the 55 to 64 answer? In other words, letter F. That is class. Did I say the wrong numbers? 38.3%. Let's see. So letter F says between 55 and 64, which is actually class 5. So if I go to class 5, here's the percentage. The relative frequency is the percentage. Do you all get that? Reagan, how'd you get 38.3? Oh, okay, you were looking at the next one. Perfect. Good, good, good. So that's this 14.4. Nope, now I'm writing it in the wrong spot. I need another monitor here. Oh, and I did that thing where I hid my thing. Oh well. So this is 14.4, and then less than 35 years old. That is below class 3, so it's these two classes together. So Reagan, correct me if I'm wrong, you added these two numbers together and that's where you got your answer.
Right.
Or you can use the cumulative relative.
Yeah, that's how I
Yes.
get the last one.
Nice. So 38.3%. Good. What is the modal class? Ooh. Anyone not know it? Oh, did y'all know that one?
Of course we do.
It's the highest one. It's the second class, the 25 to 34.
Excellent. So modal is corresponding to mode, but we have to say modal class because it's not a one data value that's repeated the most. It's the class that has the highest frequency, which sounds like you already know. So thinking about that, what would that mean for those people's insurance rates? Those 25 to 34-year-old.
It's good. Yeah, sky high is right.
Although I was thinking about this yesterday, somebody asked me about that, and it's actually cheaper for insurance companies for you to die than for you to survive.
Oh, Eric,
I mean, that's actually
it's
a big
probably
deal.
true. You're right.
In Michigan right now, right? All of our insurance rates got lowered, but all of the long-term disability people in car accidents got screwed, right? It made it impossible for the companies that were providing care to afford to provide care. So yes, I lost points on E. Oh no, the word all explains it. That's it. That's the explanation. Good catch. Yes, Misty, I think you're right. That's probably it's probably sky high. Also, if you're male, although isn't the most expensive is males in this age range. I don't know. Okay, so then how did you all calculate the mean, or did you get it?
No, because you have the numbers. I didn't type them in.
Let's do it. So we're going to do summary stats. It's grouped bend data. Now here's the tricky part. We don't know data values, but we do know midpoints. So we are going to estimate the mean using the midpoints.
We highlighted that yesterday
You got it.
and we
Okay.
said, hey, I bet you this question you'll see again.
Yes. Now, did everyone pick the unadjusted standard deviation when you did your computation for standard deviation? Remember how we said Monday that this might show up once? Well, here it did. Come on. We have to use unadjusted because that's the population calculation. This is 44.14 years old, give or take 18.15 years. That's a pretty broad range of ages. How are we doing? Is everyone okay with that? Should I redo that? Okay, awesome. I am going to wait. You use great point. So StatCrunch doesn't say adjusted, although that's kind of implied. It just says standard deviation. So it's either unadjusted, which is weird, right? Wouldn't you think that the one that isn't messed with, we'd call standard deviation, and then the one that we did mess with, we'd call adjusted? There's actually a logical reason, because there's a kind of a deeper explanation of why, but we don't need to get into it. Okay, how did we explain H? Oh, we were saying high death rate, or large amounts of deaths, lots of deaths is expensive. I mean, if we ignore what happened, like the death or like disability, what's most important here is that there's lots of crashes within this age group, right? There's 10,507 people died in a crash. Presumably there's other people involved in that crash that didn't die. So there's lots of cost. I mean, you can't think too much about how insurance companies see things, because they don't your dollars and cents to them. So high insurance rate is the point on that one. Oh, sorry, LaShawn, I keep forgetting to answer that. It should be the percentage. So it says, oh, how many fatal crashes had drivers less than? Nope, you're 100% right. Thank you for being persistent as I continue to ignore you. It's, yes, that's asking for the number of crashes within that age group. So that is the cumulative frequency or the sum of these two. So it's the 18,989. Very good. I missed that. We got it wrong in the day class.
too.
They don't know it. That's good. You're like, what's wrong with this guy? You won't answer my question. All right, I want you to either say it, mic in your answer to letter whatever this is that I can't see anymore. HI, because I comes after H. What's your answer to interpret the sentence, interpret the values in the context of the situation? There it is. Why does that keep disappearing? Wrong answers are just as good as right answers, yo. I should write the numbers back in there now that I've deleted them. I'm getting a refill while you type your sentences.
So how are you guys starting this off? Remember, there's a script. Page 78. So if you don't have it all the way done, tell us how you're starting. It's like they're all gone, Eric. They disappeared. we're just like here.
It's so hard to sit because you all, I know you all are working on it, right? It's so hard to sit here and be silent, especially because I'm recording. How about this? If you have no clue, let us know. Otherwise, if you just want some more time, take some more time.
We'll take that as more time. Okay, here we go.
Ooh. Love it. That is beautiful. Thank you, LaShawn. The problem that when I graded this on the midterm, the last time it was used as a midterm question, people were not putting age, they were talking about the number of people dying. And so they said the average number of people who died in a car crash was 44, give or take 18. So it was a misunderstanding of this. It's the age of the person that's important, not the amount. Okay, wait, the one above or the A is the thing. That's awesome. You all should be writing roughly the same thing because we gave you the sentence structure. Yeah, I better write this down for folks that watch the show. um,
The
because we-
show with,
Yeah,
with their popcorn and
yes, and probably wine, maybe whiskey. I don't know. Actually, I think I can copy and paste, can't I? So here is the awesome, I couldn't have written it better myself, answer. Can I make that text larger?
we can
So
see it.
whatever it says on like the very first column, whatever that, like, whatever it's called there, that's what we're finding out always.
100%.
Okay,
This
okay.
is the data. This is
Okay,
what we're
got it.
talking about. Good. That's a really good observation. I think in many ways, if we give you the table, it's easier to figure out what the variable is we're talking about than maybe the prompt. I mean, this like the Insurance Institute has access to the records for all fatal motor vehicle crashes. It's not clear that that's age. And then it says, and reports the following age-related information. Like it's not, yeah, it doesn't clearly say, here comes the variable. It's how old they were when they died. But the table always gives it to you. It's always the first column. If it's not grouped data, then there's only one column. And the name of that column is the data. Excellent, y'all. Okay. I think, well, why don't you all try this one, this page 3. You don't really need StatCrunch. You just need to remember how to read a dot plot. Do you all remember how to read it? Each one of these dots represents one household that was surveyed. So there are 1, 2, 3, 4, 5. There are 5 households that said, we have 0 pets in our house. And then this one is 7, and this one is 3 and 1 and 1. So I'm going to give you just 5 minutes to work on this, and then we're going to talk about it. Set a timer for 5 minutes, and then we're going to look at the quiz or the project. How we doing? I said I'd be quiet for 5 minutes, but that was 4 minutes and 30 seconds. Anyone know A? Love it. So, Misty, you're right, but you gave the wrong report. You're right to note that the 7 is what tells us this is the mode, but the data value is that these are the data values. And these are the frequencies, these dots. So the 7 tells us, yep, it's the 1. So good, you're on the right track. How many houses are in the subdivision? How'd you all get that? Or what is your answer to that?
17, you just count up how many dots there are.
Love it. How many pets? How'd you all do that? Oops. Did you do this? I believe there are 25. And then the mean, since we're kind of treating this like a group or weighted mean, the mean is 25 divided by 17. Which I suppose I should know, but whatever. 1.47 pets. Again, don't be bothered by the fact that you can't have less than a half of a pet, 0.47% of a pet. It's okay. The pet is fine. It's just, this is, if we spread them out, if we could cut them into equal parts, each person in this subdivision would get 1.47 pets. How'd you get the median? Yeah, 2 or 3. Got to be careful. That's a dangerous slope. So what do you, if you say missing limbs makes you partial of a living creature, right? We have to start deciding, what do we define as a living creature? I'm specifically thinking of humans. Here's how you get the median. Do you remember this old school thing? Put the values in order and then cancel till the middle. I think you can do it just by looking, but you're like, oh, this one, this one, this one, this one, this one. Okay, we're good enough, right? We know it's going to be 1. Even if there's an even number of numbers within here, 1 plus 1, you would add the 2 middle numbers together and divide by 2. So it'd be 1 plus 1 divided by 2. So our median is 1. Why is this person wrong? Oh, there's lots of things, right? Let's see. They didn't add up the frequency for each of these values. That's a problem. And then the second thing is they just counted how many unique responses there were. 1, 2, 3, 4, 5, right? Why are they dividing by 5? They're supposed to divide by the number of people in the survey, which is the number of dots, not the number of columns or classes. We did add in the homes that have 0 pet. Wait, let me make sure, Jake, I got your question correct for question C. I did add it in, it's just 0. We added 0 5 times, so it doesn't have any effect. So it didn't matter, it's just these that added up to the 25. 4 plus 8 is 12, plus 6 is 18, plus 7 is 25, plus 0 is 25. So yes, you do add it, but it doesn't have an effect. Cool. All right. Any questions? Set a timer for 10 seconds. You've got 10 seconds to ask a question. Okay, no more questions ever. Just kidding. I was trying to help my wait time. So get into Canvas and we are going to do, well, actually, maybe we should jump to 3.4, shouldn't we? No, let's do the chapter 3 project 1. Let's start there. It's a nice review of things we've done. It's very quick. I'm going to give you, so quick, let me calm down. Whew, deep breaths. There we go. We're centered. So you're going to day 4. And you're clicking chapter 3, project 1. And then you're clicking this link. And you can see I have 1,000 of these open right now. I don't know why. I do know why, but whatever. And recall for these projects, you need to do File, Download, and the best one is a Microsoft Word document so that you can edit it. And then enable editing, and here you go. This is a very quick project. I'm going to give you 10 minutes. Maybe I'll go do a push-up to try to keep me from talking to you. You're going to choose one quantitative variable. So we're going to go into StatCrunch, just like we did for the previous projects. So we're in the home page. If you're currently in a spreadsheet area or whatever this is called, click the StatCrunch word, and it gets you back to here. And you're going to data sets. And from that data set, you're picking a set that has a quantitative variable. I'm going to click this FIFA World Cup results and see if there's any quantitative variables. There are. Home team attendance. There we go. That's definitely quantitative on this one. So there's a couple in this particular FIFA World Cup data set. Your job is just to pick one, make sure it's quantitative variable. Tell me which set you chose. Here, you're supposed to tell me why it's interesting to you. You can't get that wrong unless you leave it blank. And then look, you're finding the mean, median, and mode. That's it. And then you're telling me, is that data set symmetric, skewed left, skewed right? Then you're constructing a histogram and saying, did that match what you thought? Okay. So I'm giving you just 10 minutes. I'm going to do push-ups and sit here. You ask us questions if you get stuck. I'm assuming you can do this. So if you want to change my assumptions, you got to tell me. Set a timer for 10 minutes. Great question. It depends on your data set, Brianna. If there are classes or things, then you would do grouped data. The one that I opened didn't have any classes in it. So when you look at this column of attendance, that's just raw data. So I'm a little out of breath. Which data set did you use? If you just do this, if you just copy this thing and paste it in the chat, I'll search for it and pull it up. Well, that didn't do it. Guess you have to select, right click, copy, paste. Yeah, there it goes. Okay, let me see if I can find it. Here we go. So when I look at this, I don't see any grouped data because there's nowhere where it says class and then frequency. So this is a good data set because these are all quantitative variables here. So you could use any one of these ones right here. And you're just going to do stats, summary stats, and columns, and pick the column you like. Does that make sense? By the way, when it says just mean, median, and mode, it means only select those. So don't forget the control mess. Awesome. And then for this one, multiple modes, nice. To copy, it does this thing. It says click on the output, drag the mouse to select a portion, or use Control A, and then do Control C. So this is a little different than the graphs. You have to select it like that. So when I click in there and hit Control A, it selects everything. Then you hit Control C, and then it will paste the output in here like this. If you're a Mac user, you're not using Control, you're using Command. Cool, carry on. If y'all have more questions, keep asking. Okay, 40 seconds, y'all. Anyone stuck on anything? Okay, I want to pull up the next project and have you take a look at that. Did you all finish this one?
I'm all good on this one.
Good. We got one. Okay. So let's, oh, there's the actual timer. So let's take a look at project 2 or chapter 3, project 2. So here we're going to be looking at standard deviation. Just remind yourself that what you're doing is doing file and download. Do that first, I think, before you mess with anything else. Enable editing. We didn't talk about how to save to a PDF again. If you need a reminder of that, let me know. So for this one, we're following this website. So when you download this thing, there's 2 ways you can mess with it. You can copy and paste this. So you can do copy that link. Or if you see what it says here, control click. So I'm holding down the control button. For Mac users, it'd be the command button. Well, I thought I was clicking it. And then you click that, and it takes you here. Okay. So it's a little applet. This is not StatCrunch. So it says click on boxes in the grid to create a distribution of numbers. So we're creating a dot plot. And the number of filled in cells in any column indicates the number of times the corresponding column's values occurs in the distribution, right? So maybe I want a couple here and a bunch there, and maybe a few, some there, maybe some here and some here. And there we go. So I've just made a dot plot. It's created some sort of distribution. And then it says clicking on any unfilled box in the column fills that. We just showed that. Clicking on the top up clears the column. Let's make sure we note that. So I'm double clicking it to clear. So notice I've got the full clicked the top one, it clears it. Click a top one somewhere else, it fills it in. So that's just how to mess with it. So note, it says the mean of the distribution is stated, and if the checkbox is selected below the grid, is located along the number line by a green triangle. Shoop. So there's my mean. I can see how it changes as I add things, etc. Okay, so we're just messing with this little applet, and the goal is to figure something out about the distribution. So you're to play around with the applet, find what it takes to make a smaller and larger standard deviation. And then you're supposed to describe what did that. Remember, you're comparing numbers. A smaller standard deviation has a smaller number. A larger standard deviation has a larger number. Here we have a standard deviation of 0. Now I've got something else. Okay, you're going to write a sentence description of that, and then first, what did you do to make a small one? What did you do to make a large one? And then what's the smallest? I think this is pretty straightforward. What you're doing. What you're probably going to feel uncomfortable with is that you have to write all these words. You think you can try? You think you can do it? Let's see, what time is it? 12:36. Yeah, I'll give you 10 minutes to try that. Okay. Set a timer for 10 minutes. If you get stuck, ask me some questions. So you're at the chapter 2 project. You open up the link, and within the Word document, there's this website. So you can select that whole thing and copy it, and then go to the URL and paste it in there. Oh, it says it's not found. Okay. So it looks like the only way to, oh, it's because that decimal place, that's why. From the non-downloaded one, if you like click that link, it opens up this little thing here. Click that copy link. And then I think it's going to do it. I'm pasting it in here. Yeah, that did it. Otherwise, when you download it,
I got it.
You got it?
Thank
Okay.
you.
I'll stop talking. Okay, we got a minute left on my 10-minute timer here. From the lack of questions, I'm assuming you all are okay with that. I think it's a great exploration of standard deviation. I want to glance at the last project for chapter 3. We still have 3.4 and 3.5 worksheets to work through. So, you know, we're kind of getting a little off schedule based on what's in the computer, and that's okay. You have these two done. We were supposed to get through 3.4 today, but I'm very happy with being okay not getting through it. So I'm looking at the chapter 3 project. It was in module day something or another, day 5. Today is the 14th. So yeah, day 5, which is the 14th. And then this one, we're looking at the number summary. So really we need to get through 3.4 and 3.5 before worrying about this one. So don't worry about that one. Let's do this. Let's write an overview of the 3.4 material. Okay. And then from there, that will bring us up to the end of class. And then we'll be prepped to we'll do the 3.4 and 3.5 worksheets and look at the chapter 3 review, maybe some questions on it in class on Monday, and be getting close to ready to get through 4.1. I'm guessing Cindy will maybe start 4.1 on Monday after finishing 3.5. So we're doing a-okay. Okay, so 3.4 is measures of position. I should pause and make sure we're all in the same boat here. Are we all together? Everyone's ready to take some notes here on 3.4 or glance at the overview of it. Ooh, there we go. So 3.4 and 3.5 are actually smashed together. So I guess we'll talk through it all. All right, so measures of position. There are 3, but really just 2. And if I'm to compare measures of position to center and spread look at all of the data values as a whole and say, what am I seeing when I look at everything? It's like looking at the forest. You get at a high vantage point and you see just the vastness of the forest, all the trees. Whereas measures of position says, where is this one data value in relationship to all of the data values? Using my analogy there, it's like looking at one of the trees in the forest and saying, what's going on with that particular tree relative to the entire forest? We have 3 measures. One of them is called the Z-score. This is going to show up big time later. So having a good understanding conceptually of what the Z-score is important. First off, there's a formula for calculating it. You can use parameters or statistics to calculate it. Doesn't particularly matter which is which. And I like to write this formula in words. So what it is you take the particular data value you're interested in, you subtract from it the mean. So this is getting how far apart the data, how far away the data value is from the mean. If that's a positive number, your data value is larger than the mean. It's on the right side. If it's a negative number, it's below the mean. And then we divide it by the standard deviation. And this tells us how many standard deviations away from the mean is that data value. This whole thing. So conceptually, that's what this is. There are no units on it. In fact, the units are standard deviations. So this thing represents the number of standard deviations a data value is away from the mean. So if we want to determine if a data value is unusual, we can calculate the z-score. And if that z-score is a number above 2 or below 2, we know it's an unusual data value, provided the data set is symmetric. Okay, so that's z-score. The other measure of position is percentile. And what this does is it takes the data values and breaks them into 99 equal parts. So we say this particular data value is the 50th percentile. That means it's at the dead center of all the data values. It's the middle value. There are 50% of the data values above, 50% of the data values below. We've got some notation for this. We do P subscript K. Is how it's written. And so P50 is equal to some number, and that some data value number, and that's the 50th percentile. And then it turns out we have some special percentiles that measure position. We call them quartiles. And those are Q1, Q2, Q3, and then really the maximum. Turns out Q2 is P50, which is also the median. Turns out Q1 is P25, it's the 25th percentile. And Q3 is P75, it's the 75th percentile. Oh, of course it did that. Okay, so then from here, I think we defined the interquartile range. Finally, this is just the difference between Q3 and Q1. And we identified what we call a lower fence and an upper fence. And you need to be very careful with these formulas. These formulas you need in your reference sheet because they're not in StatCrunch. So the lower fence is calculated by taking the first quartile and subtracting from it 1.5 times the IQR. And the upper fence is Q3 plus 1.5 times the IQR. Super easy to mix those two up, right? Just that one little symbol makes the difference between, can make a big difference there. And then this, which quartile it is right there. That's the only difference. No worries. So make sure you have this in your reference sheet. You're going to have to calculate some of these. And then for skewed data sets, skewed data set, unusual, we don't use that language. We use outlier. An outlier is any data value above the upper fence or below the lower fence. So you're going to calculate the upper and lower fences, and then you're going to be asked, are there any data values that are outliers? And you'll just look at your data set. Hopefully the data set is in order from smallest to largest, and you see, is there a number below the lower fence? Oh, it's an outlier. Is there a number above the upper fence? Oh, that's an outlier. The last thing that you get in this 3.4 and 3.5 section, you may not have gotten here yet, is the command to describe the distribution. And we'll talk more about this on Monday for sure. But the description of the distribution comes in three things. You need to state what is the shape. You have three options: skewed right, symmetric, skewed left. You need to state the center. You have two options: It's the mean or the median, and you need to state the spread. You have two options. It's the standard deviation or the IQR, based on whether it's skewed or symmetric. And if I'm remembering correctly, in this section, we finally get the big end all of pictures. We get box plots. This page is the summary of the shape and the mean and the median and the best measure of center and spread. And here's the describe the thing. Okay, so page 107 is more or less what you want on your reference sheet. I would organize it in a way that makes sense to you. But that's where we put together all of the pieces from chapter 3, all the big pieces that are going to show up a lot in chapters 6, 7, 8, 9, 10, and 11. Okay, so I think for what I would like you to do, we've only got, what, 5 minutes left, 4 minutes left. What I'd like you to do for class on Monday is, if you have time, take a look at the 3-4 worksheet number 2 and the 3-5 worksheet number 2. But also, you've got stuff for class on Wednesday tomorrow that Cindy has sent out, so make sure you're looking at those things. Cindy had to take off a little bit early today. She will be in class tomorrow for sure. Do y'all have any questions? Hopefully I didn't go too fast on all this.